Hello everyone. My name is Amit Kumar Yadav from Acropole Institute of Technology and Research Indore from third year, and I am here to explain you about homogeneous coordinate system. Like in computer graphics, many faces issue like in displaying three-dimensional object on a two-dimensional screen. Because in it we have to rotate the images and translate and also we have to scale our objects to view them from an arbitrary points. Now to resolve this issue we have homogeneous coordinate system. Like homogeneous coordinates will have some neutral applications in computer graphics, in which they form the basis of geometry which is used extensively to display the 3D objects to 2D image planes. Like it provides certain standard procedures or process, we can say, by which we can image we can graphic we can draw our image from 3D to 2D. Like what here we can see, there are mainly three types of the process. First one is translation. What does translation do? It simply shifts the object from one position to another. Like uh, we are given some point x comma y, and we want to shift it to the another point x comma y, x dash comma y dash. So what we will do is, like here we can see x1 is x plus tx, y1 is y plus ty. So x dash and y dash will be xy plus dx dy. For example, a is 2 comma 2, b is 10 comma 2, c is 5 comma 5. Now if someone asks us to translate the triangle with dx equal to 5 and dy equal to 6, so what we will do here is we will simply add it to our particular coordinates. Like a dash will be a plus t, that is 2 plus 5 6, that will be 7 8. So this was all about translation. Now the second one is rotation. Rotation means rotating of an object from a particular in a particular plane with respective angle. Like initial coordinates given to us are x comma y comma z. Now we want to rotate the coordinates to a certain angle, like we can say theta, with an angle sine. Now we can perform three types of rotations, which will be simply, we know it, x-axis, through x-axis, through y-axis, and through z-axis. Now for x-axis, x dash new coordinates will be for x it will be x only, but for y it will be y cos theta minus z sin theta. For z, y sin theta plus z cos theta. So in matrix form we can show it like this, as you can see on the screen. And same for y, what we can do here is x dash will be, we have to do now with respect to two other points which are in against the plane. Like here we are doing for y axis, we will use z and x here. For x dash, z sin theta plus x cos theta. And same for z axis also we can do. And here I have taken one example, p1 2 3, theta will be 90, and we can calculate all these things. Like x dash will be x equal to 1, y dash will be, this is for x, and y dash will be y cos theta minus z times sin theta. And what we know is cos 90 is 1 and sin 90 is 1. 2 minus no 2 cos 90 minus 3 sin 90 will be minus 3. Now for third one is scaling. Like scaling means transformation that will change the object size. Like we are enlarging the object, or we are reducing the size of the object. Like with some scaling factors, like we have three axes x y along. We have three axes x y z. Now we will enlarge it, or we will scale it up or scale it down with some scaling factors, which are sx, sy, and sz. Now if the s dot f equal to 1, f means scaling factor, sf means scaling factor. If it is 1, it means object size will not change, and if it is greater than 1, it means object size increases, enlarges, and if sf is less than 1, it means object size will reduce. Now there are some certain advantage and disadvantage. Advantages are like, if we are given any infinite coordinates, now we have to weigh how to scale it, how to use them to solve our particular query. Then what we can do is, we can just translate, rotate, or scaling. We can use any of the method and put it into a finite coordinates. And disadvantages are like, effect on efficiency requires more space. Like for 4 cross 4 matrix, it requires more multiplication and addition. So thank you.